Yeah, yeah. Yes, it is.
Okay.
Go ahead.
Okay. So there we go. All right. Thanks a lot, everyone. Good evening, good morning, good afternoon, from wherever you are connecting. This is Aman, and welcome to this session on back to basis, how select statement works. Thanks to ASEAN and the KSA Oracle user group for having me. In terms of this particular presentation, we will talk about what exactly is the SQL statements execution. About me, quickly, my name is Aman. I have been working with the Oracle database for quite some time, and these are some of the things which I have been a part of. I was one of the board members in the All India Oracle Users Group. I was the founder and the ex-lead for North India chapter. I wrote these books. I tweet here. I blog on the website blog.org.com. Okay, well, about ACE, this is something which is important to mention. Now, in terms of Oracle ACE program, this is probably one of the best community programs for recognizing and um, appreciating the professionals who are proficient in their technical expertise as well as they contribute to make others help learning the technology and solving the issues of the people in a wide area of technological subjects. So there are three levels of this. You can have quick information about this on the ace.oracle.com. If you do know anyone who is worthy to be invited into the program, you can contact on these particular channels, or you can contact Nasyam or even me. Okay, moving on. Now, in terms of the particular part of this presentation, now, first thing is, this is basically my understanding of things. These are ever-changing things. So definitely they should give an idea to you, but this is basically going to be something which you should take with a grain of salt. And this presentation is not about query tuning. So we're just going to talk about how exactly the SQL statements work. So the takeaway should be that when you're going to be understanding this particular aspect of the query execution, you should be in a better position to understand what to do in case of query tuning, if you actually want to do. But this is not going to be a presentation on that. Okay, now when we say that this is going to be the particular part, the other thing is normally this is what you're going to be the set of things which you hear when the SQL statements execution is actually discussed. So normally the presentations or the materials talk about there is an open cursor, then there is a fetch cursor, there is going to be a close cursor, which is correct. It's not that it is incorrect, but it is slightly oversimplified. The actual things are a little bit more complex. So what you don't hear very often actually is that there are many more things which are actually going to happen when the particular SQL statement is actually going to function. Again, some of these things you might have already heard, but we'll talk some little bit more details actually about them. All right, so that's essentially when the query is basically going to be done. Now, this is actually just a quick representation of the architecture in the Oracle instance. For the simplicity purpose, we're just talking about the Oracle architecture in terms of non-multi-tenant. We're not really including multi-tenant, though the things will not change actually over there since the instance still remains one. So you do have a bunch of files, and your particular statements are going to come. They're going to talk to your listener, and from your listener they're going to talk to your database instance, and then they're going to be getting the work done. Now, obviously, when we talk about the SQL statements, it is definitely not possible that we don't talk about shared pool. Now, we will have a little bit more detail on the shared pool, but shared pool is one of those particular database structures or instance structures which is actually going to be holding the basic information, or you can say the important information about query or queries. Now, there is something which most likely is not discussed, that many of these particular structures are, for example, buffer cache or shared pool. They are all actually taken care are basically maintained by a kernel layout. And that kernel layout is kind of like the OSI model, which means that there are multiple set of layers of things which are actually going to work, and they carry out different functionalities basically for you. And this is basically that set of particular layers which are actually going to be executed, and they are basically going to be doing the work actually for you. Like shared pool is managed by two layers, the KS and KG, which is kernel services and kernel generic layer. And a side note actually is that if you're interested to understand about the internal tables, for example, the X dollar tables, usually you should be actually not able to understand the meaning of those particular tables pretty much easily. A quick tip about understanding those tables is to basically look at the first two characters in the X dollar table's name. For example, if a table starts from KC, that actually means this is going to be a table which deals with the cache. So if there is a table saying KCBWDS, that particular table probably is something which is related to the kernel cache. And then the B and W and D and S, they are basically going to be about things related to the buffer cache. For example, in this example, it is going to be kernel cache buffer work area descriptor set. In the same way, there is going to be KSMP, which is basically going to be a shared kernel services memory pool, which is going to be a table talking about the shared pool. And we will have a look at that over here. Now, this is what the documentation says actually about shared pool. It's a direct link actually, and there is a direct the description actually from the documentation. So we do have parsing, we do have hard parsing, and we do have SQL processing. And the main thing which we talk about always when there is a query execution is something which is going to be parsing. Now, parsing in a very simplified term is actually going to be about how the query gets compiled, and that compilation is basically going to be kind of the governing factor, how the query is actually going to be executed. Now, in terms of the parsing, there are going to be usually two discussions, hard parsing and soft parsing. We will talk about them also. But before we actually go there are going to be some other things too, which we need to understand. And hard parsing is one of the major things which is usually going to be considered bad. And it's not incorrect. It is definitely not a good thing to have, because if a SQL statement is going to be required to get executed, definitely it needs to be having certain set of things which are important for database to have before it can create the execution plan, or it can do something called access path analysis to basically run the query. And if those particular things are not actually in the memory, then using the hard parsing, those particular structures are actually populated. And it does involve a couple of things which are very well known, like syntactical checks, semantical checks, so on and so forth. Now, the reason hard parsing is considered to be bad, because it is going to be involving doing many of the things, actually three major steps, which we're going to talk about. And these steps are going to be consuming CPU consumption. And obviously, if you're going to consume CPU, essentially, this is not really actually going to be a good idea. So the major thumb rule always is that you basically parse once and then you execute the query multiple times. Sometimes it's not possible due to a lot of reasons, but that's at least essentially is the goal. So where is actually all of this stuff happens? Now, I mentioned shared pool because of a reason, because when we say that we're doing this parsing and such, it is all basically happening in the shared pool. Now, shared pool is usually considered to be thought of containing the structures which are basically related to the SQL or data dictionary, for example, library cache or row cache, and in the recent result cache. But it is actually not just containing these. It's basically a general purpose pool, and it is basically going to be including many, many things, even for actually other structures as well. And there is a big difference between the memory allocation of shared pool and the memory allocation in the other structures like buffer cache. In shared pool, you have non-uniformed memory allocations. which are going to be one of the major reasons that you can actually have the problems like 4031 possibly there in the shared pool as compared to buffer cache. Now, these memory allocations are going to be protected by a latch, which is called shared pool latch. And these particular memory chunks are basically going to be something which are actually going to be executed by you, for example, if it is a query. Now, I mentioned that most of the times when we talk about the shared pool, we do consider that it is going to contain library cache, row cache, result cache, but it does have actually many, many more. And here is an output actually, which is basically saying that actually shared pool in this particular example, which is 19C, is actually containing 1,616 actually subpools. And this is basically going to be a reason that it is considered, if you go back and check, that I have mentioned, it is one of the most complex memory structures within the Oracle instance, if not the most complex memory structure actually. It is maintained by KGL, which is Kernel General Memory Library Cache Manager, which is maintained by the KG layer. And the memory allocation requires to be contiguous, which are going to be varying between 4 KB to 16 KB. And in case you don't get that contiguous memory allocation, you're basically going to end up with 4031. Again, we're not going to delve deep into 4031, but you should understand that this is the reason the 4031 error comes, because of the contiguous chunk of memory which is not available to you. Now, these particular chunks are going to be categorized into different components and their classes. There are different classes actually, like if you notice from the $X table KSMSP, you do have multiple such classes, which are 6 actually over here. And these are basically going to be the classes in which different chunks are actually allocated. Again, this is probably going to be something which can be useful when you're dealing with 4031, because the normal suggestion which comes in 4031 resolution is that you should be basically doing the flush of the shared pool, and sometimes that particular command does not solve actually your 4031. And the reason basically for that is that there are going to be some chunks within the particular shared pool which are actually called the reserved chunks. And that reserved chunks are not going to be freed, which is basically going to be the reason that even if you flush the shared pool, you probably are not always able to solve 4031. So there are going to be free chunks, there are going to be permanent chunks, there are going to be chunks which are freeable. And these particular chunks are basically going to be something which possibly can actually get freed. And if they are going to get freed, they can actually come back to you. And if they are going to come back to you, then maybe you should be able to solve the issue of 4031. But shared pool is basically going to be an important memory structure because it allocates two kinds of memory allocations. A permanent memory allocation, which is basically fixed, and this is controlled actually by other parameters like processes, sessions, and such. And this is going to be important because it actually is going to be used by database for many, many other things too. Now, besides the permanently allocated portion, there is going to be a dynamically allocated portion too, which actually you as a DBA controls. For example, the shared pool size parameter is actually going to be a parameter which is going to contain the library cache and other such structures. And when you're going to be doing that, you're basically able to see the particular impact of that in terms of your library cache, row cache, and such. Now, definitely, in terms of understanding memory structures, it is important to understand something about latches. Again, latches are important because latches basically are going to allow you to have access to different memory structures and to do the work basically, in those particular memory structures. And there are different latches for different purposes. Now, what exactly latches do? They basically do the part of locating a resource and then locking a particular resource, which basically means if you do need, for example, to search a query within the shared pool, or you can say within the library cache, you're going to locate that particular query or the cursor from the latch, and then you're going to lock that particular resource or the particular library cache object till the time you're not going to be done with it. And these are going to be the reasons that these particular latches are going to exist probably for every major resource or every major memory structure in the database. Obviously, they are not just for locating the resources, they basically also going to control the access of those resources. So if I have accessed something due to the circular nature of the database algorithms, you should not be able to, or database should not be able to throw that resource out of the memory. And that is important because that's going to create a chaos otherwise. So they are basically going to do both the locate as well as the lock. And that's the reason they itself become a false contention point, because if you do not have a latch actually to work with, you do not know whether the resource you're actually working with or you want to work with is actually available or not. So before you actually put a contention on the particular resource or you actually access that particular resource, you're already going to be having a contention to access the latch for that resource first. And this is definitely going to be something which isn't really that great. And from that reason, or for that reason, the latches concept is being replaced by something called mutexes, which is actually an OS concept. So you can see that when you're going to be doing lots of such lock requests, these particular lock requests are actually going to put your sessions basically into the wait. And to overcome that, you possibly are basically going to require some kind of way out. So the way out basically is that you can actually put the spin locks, and Oracle implemented this particular thing with the help of something called mutexes. Now, mutexes is actually a concept of the OS standing for mutual exclusion, or mutual exclusion objects, which are actually going to be handled by these, which means that in terms of mutexes, the resources itself are actually going to be handling their logs. And this concept is basically implemented in the query execution for the child cursors. We'll talk about what is a child cursor actually, just in a minute. So now we come to something called library cache. Well, the primary function of the library cache is to store shared cursors together with their parse tree and execution plan, as well as a pseudocode for a PLC called program unit in order to create a truly shared environment. There are many more pieces of information which are actually going to be needed, like control structures of the shared cursors, synonym translations, dependency tables, locks, pins, and many, many more. And these particular set of objects, which are basically going to be maintained within the particular library cache, they're going to be actually called as library cache objects. So the information that is stored in the library cache about these objects is basically going to be fetched from its counterpart, which is actually going to be called row cache. So the library cache stores the information which is actually fetched about the object from the row cache, and then it stores this in a denormalized form. And when you're going to make changes to these particular objects in the library cache, the changes are going to be copied actually to the particular row cache. Now, the library cache is going to contain something called library cache objects. And these objects, they are basically going to be the objects which are actually going to be considered in terms of two particular kind of categories, if you say. One is going to be the temporary objects, or something called the transient objects, and the other ones are basically going to be the stored objects or the permanent objects. So when you're going to do a create or drop of something like a PL SQL object like a view or a package or maybe a function or actually a table, they're going to be considered actually like the permanent object. And when you're going to be doing something transient, which is basically temporary, that information is basically going to be considered as a temporary object or a transient object information. For example, when you're going to be creating cursors, whether they are going to be shared cursors or non-shared cursors, they are basically going to be referred as the transient actually information. And this particular library cache is going to be maintained with the help of something called the buckets, which are going to be something maintained automatically by a parameter as it is mentioned, and you can see the information of this using either a public view or the internal table KGLST. Now, in terms of the particular library cache as well, it is going to be maintained by a latch. Now, there were multiple latches before, but the number of latches are now reduced because, like I said, the number of latches are basically a false contention point. So Oracle is actually doing basically now something mutex allocations for doing the work. So if you're going to be basically seeing that how many latches do exist before or after the changes actually. So you can see that in 10G there were 7 latches, but from 19C or the latest versions actually there is only just one latch which is actually going to be there, which is actually for the loading of these particular parts. So you can see that the loading of the cursors is still done using the latch, but most of the things like finding out the child cursors and such when a query gets executed is going to be done now by mutexes. Now, speaking of library cache objects, now they are basically going to be the objects which are actually allocated or created actually for you. And these particular objects, like I said, are basically going to be something which represent different namespaces. So if you do check the public view, you will find somewhere around 20 plus. And if you're going to go to the $KGLST, you should be able to see a lot of particular part. Now, when we say that there is going to be a particular hit or miss, or basically a hard pass or a soft pass, we are actually saying about this particular library cache object being searched, and from searched where? From the hash buckets. And if you are not able to find that particular object, library object, that means you are basically saying that you are going to be having a miss. And exactly that's where the trigger for the hard pass actually comes into the picture. Now, in terms of the particular systems, one thing which is very, very important for the people actually is that many users are basically going to be executing the same SQL statement or the PL SQL object. And to save the memory, the notion of a shared cursor is actually used, which basically means that multiple users can actually share the in-memory representation of an executable object. And a cursor is basically represented by 2 or maybe more than 2 objects within the library cache internally. There is going to be a parent cursor, which is going to be containing the name of the cursor plus some other pieces of information that are independent of the particular object, or one or more child cursors. So when a SQL or a PL SQL object is parsed, the names in the statements are actually going to be resolved to the base objects using the current context, like what is your current schema, what is your public synonym, public schema, so on and so forth. And each request is basically going to execute the statements via a different set of base objects. So the child cursors, they are actually the cursors which will contain the executable portion for your particular query. Or if it is going to be a PL SQL object, then it could contain something like a Dyna code or a P code, basically from your particular system. And obviously, these particular cursors are going to be the in-memory representation. So they are the transient objects, as we actually mentioned. So you can see that the library cache is basically going to be contained or maintained with the help of something called hash bucket. So when you execute a query, your query is going to go into a particular hash bucket. And this hash bucket is basically going to be having the particular hash key and values actually maintained. And using these hash keys and values, they are going to be actually grouped. Now, obviously, if you're going to be basically running this particular query or queries, if within your particular hash bucket, Oracle is going to find the particular object handles that you're actually looking for, and they find the matching ones, that means you're actually able to say that you got basically the particular query figured out or checked out. Now, this is actually an important thing because the library cache is basically going to organize things in the hash buckets, and the hash buckets are basically going to contain something called object handles. And these object handles are basically going to be some things which are going to be represented with the help of something called the heaps. So library cache essentially is a hash table, which is basically going to be accessible through an array of hash buckets. Each bucket will give an access to a linked list of library object handles, and these library cache objects are made up of heaps, like I said. All the object handles, they will point to the first of the heaps called heap 0, which is what I mentioned here. And this heap 0 will have the pointers to the other heaps. For example, the heap 6 is actually about SQL statement. Now, Library Cache Manager or KGL controls the access and usage of these library cache objects, and memory for the library cache obviously comes from the shared pool. Now, in terms of this particular object handles, these are basically going to be the objects which you actually will find. And you can see that these object handles are of different natures. Now, heap 0 is one of the most important structures because, like I said, the heap 0 contains the information actually about the structures which are going to be stored, and it has many different components like what type of components you have, whether they are tables, locks, and such. And this particular set of structures are basically going to be organized into object types. So there are different object types, and the numbers are basically dependent on what kind of objects we are maintaining. So we could be having a cursor, we could be having a table, synonym, sequences, whatever. So there are multiple namespaces like categories to which these object types actually belong to. And based upon that, the objects are actually going to be, accessed. So obviously for us, like if you're talking about select queries or SQL statements, the SQL area namespace or the object type is actually going to be the most important one because that's where the SQLs are actually going to be maintained or actually stored. Now, obviously, you do have object names. If you're running a query, obviously you do have object names, which basically is going to be for library cache objects. So there could be having a schema name. If you're running an anonymous PL SQL block, obviously it is going to be blank. Then data dictionary object name. So that is going to be, again, you might have for shared cursors, you're going to be having, like, for example, select star from employees. So if you're going to type select star from employees, then you will have a different shared cursor. But if you're going to type select star from HR.employees, it is actually going to be different because of the difference in the characters. Then there could be data links and such. You could be having the particular informations which are basically going to be whether the objects are public or they are private, or they are basically going to be having some special status. So if the object is basically pinned, that is meaning that the object is actually existing. It is existing in the local system. The object could be actually dropped, and that status is going to be shown there. Some special status which are protected by the library cache latch, they are going to be there. Like if the object is valid, then there could be a status. If the object is authorized, there could be a status. It has compilation errors, there could be a status, so on and so forth. Now, these object tables are basically going to be some things which are actually in multiple different internal tables. Again, I'll not take time because I think we have limited time actually, but just to give an idea that if you have a dependency, for example, when you write a query, obviously a query is going to be written on a table. So that means when you say there is a cursor, that cursor is dependent on a table or maybe tables. So each entry in this dependency table XOR is basically a pointer to a physical location in the memory that contains the object handle for the object it is going to be dependent on. And then there could be a child object. So like I said, there could be a parent cursor and a child cursor. So there will be an entry for the child cursor. So on and so forth. Again, we don't have time to discuss these things, but each of these library objects, for them, different tables are actually going to be maintained. And this is where the point comes of different heaps actually. So as I mentioned to you that there are multiple data heaps, and 0 is basically going to be the important heap. And then there are other heaps which are actually going to be there. So the heap, which is heap 0, contains the object structures, including the associated tables and data blocks and maybe pointers to the next heaps. And obviously, this is going to be something which will change or changing actually depending upon the version. So these heaps are basically going to be something which are maintained by the system. And there are multiple such heaps which actually do exist. Like for example, heap 0 is for the object. Heap 1, which contains the source code, probably for your PL SQL objects. Heap 2 and 3 contains Dyna codes and P codes. Heap 4 contains the machine codes. Heap 5 contains the errors, which are basically compilation errors. Heap 6 contains your SQL text. or context actually, which means heap 6 contains your context information for a shared cursor. Heap 8 to 13s are basically going to be the subordinate heaps, and depending upon the requirements, they're basically going to be used. So you can see that the heap 0 is basically from where the entire object, its information, as well as the dependent tables are basically going to be maintained. So when you're going to go to a particular hash bucket, from the bucket, you will go to object handle or handles, and from there, you're going to be routed to the particular heap 0. And from there, you can actually be looking at the information at different heaps. So the SQL statement search is basically going to be done that you're going to come into the UGA, from the UGA to the CGA, and you're going to be basically saying that, okay, I want to run this query, what to do. So a syntactical check will be done, a semantical check will be done. You're going to be searching for the query using the hash. And once you're going to be actually doing it, you're basically going to be getting into two kind of situations. Once you're going to be actually checking this particular thing, you're obviously basically going to be requiring that you're going to be, finding out basically the particular part, the of library cache pin. And once you're going to be searching, you possibly can be at two different, outputs. You could be possibly having the cursor found, it's a soft parse, or you possibly have not found and it's a hard parse. And that's basically the main point. So how this particular thing is actually going to be done, this is basically again using the hash bucket. So you're going to be having a query, which is basically required to be searched. So you execute a query, and when you execute a query, you're basically going to do the hashing of this based on the ASCII key characters, and a number is going to be generated, which is basically going to result into a key value pair. Now, each of these buckets are basically going to be owned by the particular hash keys, and the value represents your cursor representation, which is why the text of a query is really, really important. So you're going to search in a particular bucket, and you start searching in that particular bucket for the matching library objects, which must match exactly with your query. So what we are representing here is actually the multiple child objects or child cursors which possibly are available. If your match is searched and found, it means it's a soft parse, and if it is not, it's actually a hard parse. And that's basically is what is parsing actually happening. Now, because of the lack of time, I'm going to just put it over here, and when you're going to get the particular slides, you can, or maybe in the recording, you can just pause it and read it from here, that there are many, many things which are actually happening before actually you're going to reach to the part of the syntactical check. So you can see that the step one, they're all basically the steps happening in one by one particular order. And you can see if I go to the next part, that's where the particular heap 6 is allocated, and then the syntactical check is performed, and then the semantics check is performed. What you're seeing actually over here in the bracket or the braces is basically the functions actually which are doing these particular activities. So the PRSCMD is a syntactical check function, or you can see the routine, which is doing the work. Then the access path analysis is basically your execution plan creation. Then you're going to read this execution plan. You're going to be unpinning the particular KGL structure. You're going to unpin the NQs, and that means your child cursor is now going to be added for your particular parent's heap 0, which is, again, if you forgot, the heap 0 is basically going to be the parent structure or the parent heap from where everything is actually going to be started from. So hopefully that makes some sense. I'm sorry. Now, when we're going to talk about this particular library cache, you can go ahead and basically trace it if you do want it. Will be a fun thing to do, actually, a rabbit hole, and these are some of the particular levels you can actually do, and I've mentioned what each of these levels actually do. So if you just want to do a simple analysis, maybe just level 2 is fine. If you want to see basically something more, and then you can keep on doing the higher level tracings, and you will see something like this. This is very, very small output snippet that I have actually done and pasted over here. Now, you can see the parsing activities from a lot of ways. So you can check it from the VDOL active session history, from the VDOL SQL areas and such. But the common question which we do get very often is, what exactly is a cursor? Well, cursor is basically a data structure. And that cursor represents or is represented by two particular parts: a private, cursor, which is non-shared, of course, and a public cursor, which is actually shared. Now, the non-shared cursor basically holds the data set, and that is going to be under the CGA, which is the cursor global area under the PGA. Now, this is something which is created by you. That means you means the client program, and this is basically going to be done implicitly for implicitly executed, queries, or if you're going to be running something like a explicit SQL cursor, then it is going to be done for that. And then there are shared cursors. Now, that's something which you might hear quite often, actually, that you have public cursors, which are actually in the library cache. I hope that makes sense. I'll just pause over here for a minute to see that, okay, there are no questions. So hopefully it makes some sense to the people. All right, so I think there are no questions, so I'll just continue. So now these public cursors, which are actually in the library cache, they are the ones which may not always be shared. And I'll show an example to you of that. Now, these shared cursors are basically the ones which are further divided into something called a parent cursor and a child cursor. Now, the point comes, what exactly is a parent cursor and what exactly is a child cursor? And also, they are, maintained by something which is actually going to be considered as a breakable parse lock, which means to understand that when a cursor is created, a lock is actually allocated on it. Imagine that you have a table. On that table, there is no index. So when you run a query on this table, you're basically going to get a particular plan of full table scan. The query is hard parsed, and you have basically a plan actually available. Now, let's suppose you make an index on this particular table. There is already a plan in the library cache. How come Oracle can actually discard it and basically check the index analysis on this particular table now? They can't. There is already a cursor. As soon as the object structure is modified, immediately, now that is why you must be told that do not gather the statistics when you do have the queries actually in use, because it is going to do this lock breaking, hence the name breakable, of this particular cursor. They're going to break the lock on this particular cursor in the shared pool or in the library cache, you can say, and they're going to mark it as invalid. And because it is invalid, again, there will be a hard parsing, and now the index access analysis possibly could be checked out. And that's where the difference of the multiple child cursors possibly may come. Now, making this into consideration, now what exactly we have basically here is that parent cursors are basically the representations, or you can say the templates actually, which are created for each query. Each parent cursor may have multiple child cursors associated with it. And you're going to have their parent cursors mapped in these particular tables. Now, each parent cursor may have one or maybe more than one child cursors in the shared pool, due to the reason that the previous child cursors may or may not actually be shared. And for two child cursors or multiple child cursors to be shared, they must be identical in every aspect. Otherwise, they're not going to be shared. And if they're not going to be shared, the reasoning for that will be actually visible to you from the particular, either this table or this particular view. Now, here is an example of this particular parent and child. So what I'm doing basically is pretty simple. I'm creating a table from the departments table, and I'm flushing the shared pool. And if you notice, I'm just running a simple query. We actually are told very often that there is a case insensitivity in terms of this particular SQL queries. And that means if you run a query by SQL query, then it is basically going to be case insensitive. Now, do notice that there is no change in the output, which is obviously expected. But you notice that when I'm looking at the internals, I'm actually seeing that there is a parent cursor allocated in the VSQL area for lowercase and for the uppercase. And you can notice the SQL handle and the SQL ID is actually different for each. And there is a hash generated for each of these basically. And for each of these parents, there is a child cursor. The zero is the first one. There is a child cursor which is allocated. Now you can notice that each of the cursor is executed by the same execution plan, which is fine because the plan is full table scan anyways. But the cursor is actually executed by a different hash value. Now, to look at the output in a different way, now you notice that we are actually having the particular alter system command done, and we are executing the query in the same text. But we are changing the optimizer mode in the first example by first rows, in the second example by choose. And now you notice a totally different output. You notice now there is single parent cursor, which is actually created, but it has two versions which are represented in the library cache. Now, if you notice the child cursors, you notice that they do belong to the same parent. Everything is same. There are two child cursors created. They are actually same and they are representing the same parent. But still there are two actually which are created, and because of the reason they are not shareable. Now, the reason they are not shareable, as I mentioned to you, that if we check from this particular view, we can actually find out that we have, now obviously because it's my demo, so I know that I have done an optimizer mode mismatch, which is the reason actually that these cursors are not shareable. And because of this very reason, this is going to be a problem for you, that you're going to, end up with a lot of cursors which basically are just going to be sitting and getting wasted, especially when you're going to be actually not using the bind variables and such. So you can see that there are many different reasons, and to make the life easier, Oracle added, if I remember correctly, 11G, a reason column, which is actually a CLOB column. So you're, instead of searching each column one by one, yes or no, you can just query this reason and you can actually find out. So what is a cursor anyways actually? Basically, it's a bridge between the client's PGA and the server side's shared metadata structures. And now comes the parsing. So we understand what is query, what is actually the queries, this thing called, structural information and whatnot. Now we come to the part of that, what is the parsing? So there are going to be three steps which are basically executed for the query parsing. And we'll talk about them one by one, not in detail actually, because each one of them is going to be too much and we are having a limited time. I think I'm already going to run out of time. But the first one is query transformation. Think of this as that Oracle tries to simplify the query in every particular way possible. The important word is try. It's not that they always can do it. It's not that it is a must to do the step, but they will try. And they will try in the sense that if it's a possibility to simplify the query for the next step, can we do it? And you can only see this transformation in either the execution plan or in the optimizer trace of 10053. There are multiple transformations which are actually possible, like rewrite, predicate push, transformer transitivity, view merging, so on and so forth. And this transformation phase is basically going to lead to the estimation phase, which is, if you remember, I mentioned, and where the term of cost is actually going to come into the picture. Now, estimation phase is that Oracle is going to now check the selectivity and cardinality of your particular query, which is one of the two components, which are the two components basically for finding out the cost of a query. So what is the selectivity, which is basically a percentage to find out that how much amount of data we are expecting to see basically from the query's execution. So, for example, we have, let's suppose employees table, we have 14 employees and they're all unique. So if you're going to search for employee number 7369, the selectivity is going to become, because it is all unique values and the selectivity formula is 1 by number of distinct values for an equal to sign. So it becomes 1 by 14, something like 0 point something, 7 something it is going to become. And this data is going to come from your statistics. So the statistics will play an important role to understand that where do we actually stand basically over here? Like, do we have the data which is unique or non-unique, or all that part. If there are no statistics, then they will at runtime use dynamic sampling to come to this number. And using this data, now that we will try to find out a reasonably close number, actual number, basically for the parts. As I mentioned that the value is 1 by 14 for 7369. So there are 14 total rows actually in the table, which means the expected number for the particular query to result the value is 1. So cardinality is basically the particular number of rows actually which you notice basically in the query. So this is basically your cardinality, right? Represented by a card actually. So these are the expected number of rows actually. So you can see that cardinality is based upon selectivity into total number of rows. And this is basically going to represent something called the cost, or at least a projected number based on the object and on the system statistics both. And the cost of a query is not representing the elapsed time. So you can't say this is 3 seconds to run the query or 3 milliseconds or whatever. And this is actually also controlled by a parameter which can be having two different values. One for the CPU, which is a default, or it could be IO, which is not done because then you have to do the IO calibration and you have to check actually that what is the queries basically IO calibration for the storage. And that can be hard to do. So they basically do it for the CPU. But the cost of a query is actually evaluated by this principle, or in simple words actually, it is basically the single block read execution time basically for your table. That means in how much time a block is going to be read from the disk to the cache. And because obviously this is a number which is going to be represented by the OS level statistics, it is actually going to be maintained into this particular table, which is called auxiliary statistics. So this table, if you notice, is not populated by your object statistics. It is going to be populated by your system statistics, which you should actually gather definitely. So like I said, this is what I mentioned, what impacts the cost, obviously the statistics, definitely the level of statistics and system level statistics too. You can actually gather different levels of dynamic sampling, which are basically going to be having changes like you do have 0 to 10. Actually, the previous you now have 0 to 11, which means even if you do have statistics available, Oracle can still try to gather it using something called cardinality feedback path. But in general, you should actually be able to let Oracle, do the work with the help of the automatic sampling, which they're actually doing. That should most of the part do the work or do the magic for you. Once you've gotten the statistics, you've gotten the cost. Now the last part is to create different plans, which is basically based upon how many plan permutations Oracle can actually do. Again, these are the maximum numbers, but that doesn't mean that Oracle is going to create 2000 plans for every query. That depends actually on what kind of query you're basically doing and what it actually can possibly do. Like if you're going to be having select star from EMP, obviously they know that there is just one execution plan possible or variation possible, which is full table scan. And obviously based upon that, they're going to actually pick up multiple execution plan analysis, and based upon that, they will pick up the least cost one. So now the soft parsing. Well, the soft parsing is that they already have done all the hard work which we have mentioned, and now that statement is going to be in the library cache. If you're going to have the statement fired again and everything else like hash value, select statement, and text, everything is found exactly the same, this is now going to be considered as a soft parse. It is slightly better than hard parsing, but the actual thing is that you possibly are still possibly going to require to make this thing workable. Like obviously the statements have to be identical, they have to be shareable. So if you're not using, for example, bind variables, you might have to use cursor sharing parameter with the values force and exact. Similar is still there, but it is deprecated. It's something which you can use, but you shouldn't. And bind variables obviously are going to impact the performance, but they can also impact the performance in a bad way because they can introduce something called bind variable peaking. And to overcome that, Oracle basically is using now something called adaptive cursor sharing, maybe a topic of another day sometime. But the important thing is that whether it is hard parsing or soft parsing, you should actually try to not do both actually. You should try to go for something called the no parsing. And that basically means that if a query is going to be understood to get executed again and again, you possibly can store the query or the query's address in the PGA, and that means the search of the library cache hash chains to find the object handle basically of the library object, you actually can skip that particular part. It will not make your query blazingly faster, but it is still actually going to make the query workable, or at least will give you some benefit. And that is implemented through the session cached cursor parameter. It has a requirement that your query must execute for more than 3 times. Or if you're using some Pro C applications or something like that, you can use also hold cursor and release cursor. And this is something which is going to be considered as the soft parsing or no parsing. And we can show a demo, but this is not needed. If you want to track this, there are two statistics basically which are evaluated for this, that when the first time statement is going to be called, it is basically going to be considered. Then the second time authentication is going to happen. Third time, the query is going to be called. Fourth time, the cached version of the query is going to do a hit. And that means you're now basically doing the no parsing. So this is actually a number 50, which is for per session, should be definitely increased for at least like 1,000 or 2,000, depending upon what work you do. But this is enabled by default, though the number is actually very small. Now, what is next? So once the query is now ready to be executed, it is going to be executed. And that's where the part of buffer cache comes. Again, buffer cache, I have a different presentation on how the buffer cache actually works. But once the data is going to be fetched from the disk, it is now going to be put into the buffer cache. And from there, it is going to be returned to the client in array fetch limits, which are basically going to be different limits in terms of the data is going to be returned to the client. Like SQL Plus, this limit is 15, JDBC it is 1, so on and so forth. Now, when the last row is actually going to be returned to the client, or you can say the entire data is returned to the client cursor, which is what I mentioned to you in the PGA, is actually going to be stored, and the fetch is going to close the client side's cursor, which is what should actually be clear to you now, that the open and the fetch and the close is basically for the client side cursor. And that is basically what the final understanding you should have in terms of this particular part, that how the SQL statement basically comes to the close part. So what is going to be the takeaway? It's a pretty complex process. Hard parsing and soft parsing, they are two integral parts of it. Hard parsing is obviously unavoidable, but soft parsing is something which is something that you should aim for. And definitely you should aim for no parsing too. And especially if you're doing the queries, tuning, you should try to not really pay attention to the physical IOs, because they're going to be taken care automatically if the query is arranged properly. But you should try to pay more attention to the logical IOs, which are basically the IOs from the database buffer cache, because even they are going to be requiring the latches required for accessing of the data. And of course, the number of times you will travel between the client and the server is going to be represented by your array fetch. So try to reduce those round trips as well. Write a good SQL so that you actually end up with a good execution plan. So instead of searching for internal parameters and whatnot, basically to look for the query, you possibly can just write a good query and be done with it. And obviously gather the statistics, or let the automatic stats basically handle that particular part, and that should be actually good enough. And that's pretty much it. So thank you. Thanks a lot. This is what my Twitter handle is. You can actually go here, and yeah.
Thank you,
Okay.
man.
Thank you.
So, there are any questions? You can self unmute and then you can start questions if you have.
I believe not. I think we have confused people a lot on a Saturday evening.
Okay, fine. Okay, I think we are good.